Hello, everybody. So on to week 2 tonight of Intro to Software Development. We've got quite a bit to go over this semester. I've got some stuff this evening I am going to be doing on my laptop. So I'm going to have to find a good spot to sit for that. I was waiting until the Zoom meeting started. I think if I sit right here, you'll be able to see me on the camera with the laptop, hopefully. We'll get to that in a few minutes. But there's some things that are on I have on my machine that aren't here, so I want to deal with those. Deal with that when it comes up. So first thing on the to-do list tonight is a reminder, or perhaps a reminder. Perhaps it's the first time some of you all have heard this. But here at Sellersburg, there is a computer club for everybody in the School of IT. And our dean, Skip, you all met him the first week, if you hadn't met him before this semester. He's a very proactive person. So I know at one point in the past, every student in the School of IT was automatically signed onto the roster for the computer club. Looks good on resumes and stuff, but we do some other stuff. There's regular meetings, different events for special occasions. Before COVID shut everything down, it was pretty common that on Friday afternoon we'd have LAN parties. We'd kind of commandeer a classroom when campus is empty on a Friday afternoon, get some pizza and wings and all sorts of stuff, and have a big LAN party, play games all afternoon. So the computer club does do some fun stuff like that. Now that we're getting back on campus, some of us, there's 3 of your classmates here tonight. I guess the camera's not really picking them up. We're computer people. The back row is much fuller than the rest of the room. But thank you all for joining us here. Thank you for calling in on Zoom. I still have a feeling there's going to be some adjustments to the blended format, but we'll deal with any problems as they arise. Do you have a question, Zach?
Yeah, it's still being a bit slow.
Maybe it's just really slow. Too many units. It worked when I tried it. If not, I'll pass the word on to Keith again. I didn't know about that. Okay, yeah, so just a reminder about the computer club, and I guess everything else on my to-do list here has to do with writing code. So the first thing we want to consider when we're writing code, has everybody seen the temporary username and password? Looks like I'm a little restricted on space to write here, and glancing at the video, it looks like I might need to write a little bit bigger. Remember, if you're seeing everybody's pictures, kind of like what you're on the board, if you go up to the right-hand corner, if you go to speaker, then my video should be bigger. But
you can also spotlight it, which forces it out like that to everybody.
yes, there are different options. Different ways to set it. So you can set it so that the screen will show up a little bit bigger. What's being broadcast will show up a little bit bigger. Hopefully make it easier to see what's written on the board. So for this class is about studying the concepts of programming. And this kind of break out a little. Yeah.
It disappeared on me again.
Try that one. See if one of them works. We'll check on that in a little while. It's not too critical because if we can't set up accounts, they're not going to remove the password. But just check every time you come in and see if you can set up the account. You should be able to before too long. Okay, so getting started into our course material. It's programming, learning programming languages. And even though we're going to work primarily in Python in this class, notice I did say languages, not just language. There's a lot of commonality. Everybody in here would have had the SDEV 120 class, Introduction to Logic, doing the basic components. We'll kind of do that again here. We'll stretch it out, spend a long time detailing about how to do those. Lots of lab time to actively practice things, different exercises to just apply those skills and get used to it. And most of our languages are very, very similar. So once we see the tools, we'll be able to just adapt what we know about how selection structures and reiterative structures or loops, how those go together along with variables and lists and things in order to put together a program. And then we just need the syntax for the particular language. So some of the people on the list here were also in my afternoon class, the game development class, and kind of what we did this afternoon. What we did in an hour for the Python programming language, that's what we're going to do over the next 5 weeks in this course. But then, for those who saw that this afternoon, what we did in that hour of just apply these concepts that we know about how the logical structures fit together to create a program, we'll look at the syntax in some other languages and then hopefully be kind of familiar with them. But you always want to start and learn one really well. So that's what this class is focusing on. We're learning Python really well, which is the most popular language in the world right now. And one of the nicest things about Python is everything about the language was designed to make it easier for the human to use. A lot of changes, a lot of the arbitrary symbols we see in other programming languages were removed in Python, such as semicolons. And the C family of language, a semicolon means end of instruction. So every time we get to the end of an instruction, we have to actually put the symbol in that means end of instruction. Like X is assigned 2, end of instruction. Y is assigned 5, end of instruction. Z is assigned X plus Y, end of instruction. We have to put that everywhere. So to make it a little bit easier in Python, they did what's more natural to humans and made the end of instruction character the line break, which means white space matters. And looking for a missing semicolon or an extra curly brace or something is nothing compared to looking for the missing white space. It can be a bit of a headache sometimes. So it's nice to have tools that help us find problems. So that's what we're going to look at first tonight, where we write our code. And just before we started the video, so before we get into all of that, there was a question about the textbook. So I was going to pull that up and kind of see if we can get on the textbook. So who was it that asked? Was that you, William? And then
Yes, sir.
Oh, I'll say a bad password.
Yeah, I lost you there for a second.
I'll try that one. Oh, sorry. I was just signing into Ivy Learn. Oh, I should share my screen. That's why the Zoom call seems to be in delay. There we go. So you should be looking at my screen now. So we come into our class. Oh, that's the wrong class. We click on the right card to get to our SDEV 140 class. There's the link for Cengage Unlimited, but we have to check. We have to go in through a homework assignment first, because all of the access codes and everything are already built into the Ivy Learn shell, so we don't have to worry about them. So you'll just go to modules and then find some textbook assignment here. So like programming exercise 2.2. You click on that and get this and load this in. We're able to get this far, William, or anybody else that was having trouble.
Those steps worked for me. I can confirm.
Yeah, I wasn't sure it translated to the bookshelf.
Yes. So once we go in this way, that passes all the codes and things through. It's going really slow. I'm not sure why. I'm gonna go ahead and close because I've already done this. So once that loads up, then you should be able to come over to Cengage Unlimited. And I'm not really sure why I clicked on that because I see a different page than you all. And last week, somebody said that there'll be a drop-down menu there. Yours looks different than mine. I don't know why I clicked on that. But when you go over to the Cengage dashboard, if you go to the drop-down menu that has rental options, you should be able to access the textbook that way as well. And that's the steps that are supposed to work. If they're not working, you might have to do some more in-depth troubleshooting. But usually in the modules, once we get into the textbook, if it'll load this time, I clicked on a different one. It doesn't have to load that whole sandbox.
Do I need the number lock on?
It just depends on if you want to use it or not. On your keyboard?
Yeah, because for some reason my password isn't working.
So if number locks on, then you get the digits here. But if number locks off, then those work as arrows and navigation buttons. So you probably want it on for a password. Yeah, if you go into the reading, once we're in the textbook, you should be able to get to table of contents stuff somewhere. I'm not sure where the table. Nope. Oh yeah, then the top button will show what you have access to and all the different stuff. But once you're in the textbook, any way you can find to get there should work. But after you've gone through the assignments, you should be able to get through it with Cengage Unlimited. You might have to choose some different options, like and somebody said last week, the rental options work. But one of the things in here, let's click on this, see if it loads this time. When we go in the book, this one that was taking a long time to load, what takes a long time is load sandbox. It needs to load something that we can type and run Python code here on the right in the textbook. And a place where we can put together our code and run it and has the basic features. That's what we call a development environment. Oftentimes we refer to it as an integrated development environment. Hopefully those words are kind of showing up on the video. But an integrated development environment, which is a mouthful, and as always in IT, we just take the anagram for it. An IDE is the place where we write and develop our code, which they included one in the textbook. But this is the bare minimum one. It has a text editor where we can write the code, write up the text file that is in the Python programming language, and then the run button. So not very many features to work with. So on these assignments, you'll probably want to open up these starter files and copy and paste them into something else. So I want to start by looking at IDEs, the places where we write our code, and some of the features we have there to kind of help us get the code written. So I'm going to close that. And while I was doing that little intro, were you able to get a little further into the textbook there, William?
Oh, yeah. Yeah, it popped right up then.
So I'm going to use my laptop here, which I don't have any sort of good place to put it where I'll still be on the camera, so I have to be in a seated position. I don't think I like doing this from a seated position, but I'll be sharing the screen. For those here in the classroom, are you able to see the screen here, or it might be a little bit clearer on the actual video screen than the projection? Or you can log on to the Zoom call. If you can log on to the Zoom call for these. Well, here in the classroom, we all have two monitors, and that's going to happen a lot. even before everything shut down, I was using Hangouts, Google Hangouts to broadcast my screen during classes because class involves examples, which means following along text files, which is kind of hard to read projected across the board. I can write really big, but text is usually going to be kind of small. So I would always project that. So the Zoom call kind of works for that. You can project it across here. Oh, somebody's coming in. Oh, I should have expected that. I don't know why that was a surprise. And that might make it easier to see. So our most basic text editor, for the most part, we're going to be using IDLE, or we're going to be using Python this semester. So when we install Python, one of the text editors, there's a small IDE that comes with it. Just has sort of the basic features, and that's called IDLE. While this opens up, I'll clarify what I just misspoke there. I said that we'll be using this mostly. Mostly, since everybody's going to be using different IDEs, I will be using a stripped down, most basic text editor and command prompt for the examples. In particular, I'll be using Notepad++ because unlike most text editors, Notepad++ does have zoom functions. So I can zoom in and make the text look really big on the call, or zoom out and see more of it. But after you install Python, in the start menu, there should be a folder for Python, and in that is IDLE, which is the most basic the most basic thing that we would call an integrated development environment. As technically that thing in the textbook does have that I there, but if all it has is the text editor and the run button, that's a little smaller than what we normally consider IDE. We want more features. So IDLE comes with a shell where we can run the code. That's what opens by default. And if you come to the file menu and under new, there's options for a text editor opens up. And I believe a number of people did pick Spider. So after we go through these features in IDLE, which is the most basic one, we're going to go through these in Spider, which has much, much better features. And depending on how time goes, we might look at a third one. But once you've seen the full featured thing in Spider, whatever IDE you chose, you should be able to find those same features there in the IDE of your choice. I jotted down some notes for this, so I'm going to pull those up, make sure I don't skip anything. Let's see, like I said, and for the most part in class, since everybody's going to be using different IDEs, I'll probably be using the stripped simple text editor, probably Notepad++, and command prompt or PowerShell to run that code once it runs. But as long as you have a place to type the code and write the code, it'll be okay. The most basic things we want in an IDE, there's probably 4 features you want to look for. And that's a text editor to write code, that's obvious. A console, a shell, or a terminal to run it. And then like command prompt in Windows, or bash terminal, or Zeech terminal. I guess Mac is insisting everybody updates to Zeech now instead of bash. Most people are still using bash on Mac, but whatever console comes with the operating system, we can run it there. Or like in IDLE here, we have some shell specifically for running this. So we do have a run button, or just hit the F5 key to run the code instead of going to the command prompt or bash terminal and typing in the instruction. But we want some debugging tools. That's what's missing. That's what we probably wouldn't call the thing in the textbook a full IDE, because it doesn't have any tools to help us when something goes wrong. So I'm going to write a super stripped down example here. The 4th thing we probably want is some telemetry, which is tools to analyze and gauge how our software is going, efficiency and things like that. As far as us in this class, if efficiency is a worry for your software, the first rule is pretty much don't use Python. It's about the least efficient language ever because everything about Python is to make it easier on the human. So all that stuff that makes it easier for the programmer got passed on to the machine. So it is not efficient, but machines are really, that's not as big of an issue as it was in 1990. In 1990, that was a big issue to be on a slower language. But nowadays, a slower language has to get really big before that becomes a problem. But we do usually want those telemetry options, something to say like, this program's using 3% of RAM. When you tie that in with everything else that's running on the operating system, how's that gonna affect things? Usually speed-wise, there are other issues, but really it comes down to speed is what we care about. So idle is the integrated development environment that comes with every installation of Python. You install Python, you have this. So we can type code right in here, like assign some value to a variable called X, some other value to a variable called Y, and then do our math. Z is going to be assigned X times Y, and print out Z. So we can type our code right in here, line by line, run all the instructions. If X is greater than Y, then print big, otherwise print small, and hit enter a couple times after we do all the indented stuff. But you can see the indenting looks a little bit funny here, because the one by the terminal gets indented, and then the subsequent lines are pushed back over. It's a lot easier to type all the code in a text editor, and then we can just run it over and over again to kind of get the same features. So I'm going to put some value in A. I'll just a simple example. So I'm going to assign some variable. I'll call it X. Keep it simple. We'll talk about variables soon. We probably don't want to use X and Y. Right? We use those in math class because they're quick and easy to write. If we're writing on the board, I'll probably abbreviate short abbreviations and short letters, but don't be lazy with typing. Be specific in your variable names, because typing's easy and that helps to clarify your code. Helps to keep track of what's going on if the variables are all very descriptively named. I'll make notes about what I want to do in the example. I want to do a couple print statements, so I'll just do this. So print the first number is plus whatever's in X, and then print the second number is plus whatever's in Y, then print, then I'll calculate Z equals X plus Y. Just a simple calculation because we're really looking at the environment here, not the basic code. So these are some of our basic commands. I don't really talk about print. Print is spit things out to the console. So whatever value we have, spit it back out. The sum is, their sum is plus Z. So there is a problem with this. Some of y'all might recognize it, right? With what I just typed. I'll run it here in a second because one thing I like to do in lectures is instead of showing you the finished product or what it needs to look like, I like to actually throw the error messages and talk about how to interpret them and fix the code, which is kind of the main thing where we're starting out with the integrated development environments to look at the problems we have. So once we type up all our code, we hit Control S to save it. And one thing that's really, really useful in idle is sometimes we need to know where Python is installed. And if you just start navigating around the folders, by default, Python would have installed someplace that is in hidden folders. So you have to turn on all the hidden, make all the hidden folders visible in your operating system and then navigate through it. But when you first open idle, it will try to save where Python's installed at. So you can always just open idle, create a new one, and hit save, and then copy that from the address bar to see where it's actually saved at. But that's probably not where you're going to save your script. So you just do the normal navigation to wherever you put your code. Example idle, I'll give that a name. And then once it's saved, then we can run it. You can either come up to the menu here, hit run and hit the run button, or if you just hit F5, it'll reset the shell and run. And here we got an error message. So I like to actually throw the error messages in class and talk about them because, like, the textbook shows the finished product, right? If you go online and look up tutorials, they show the finished product. They don't tell you necessarily how to fix things when they go wrong and how to interpret these messages. So if we look at this message that popped up here, actually I can write on it in the Zoom call, can't I? That may be better than circling things on the board. I have to use this machine to do that. Probably can't do it very clearly with the mouse pad. I'll try. So if we look through here, trace back, that means it's going to go through the last few lines of code that ran. Probably not purple here. Let's try. I'll go with black. So it's going to look through the last few lines of instructions that ran. This basically the computer's going to rerun the last couple instructions to see which one failed. And once it confirms where the failure happened, it'll tell us what it could detect. So here it's saying on line 8, there's a problem. And the problem, then it says what type of problem it was. We had a type error. So type, that's our data types, integers, strings, floating point numbers, booleans. So there's some sort of error related to the type of data we ask it to work with. And then some sort of message. Can only concatenate strings. Cannot concatenate integers and strings together. So what that error message tells us is that we tried to print out integers, but we can't print integers to the console. We can only print strings, so we need to cast that into a string. And to do that, we have a pre-built method. Looks like this, str, and then the value that we want to turn into a string gets wrapped in parentheses. We'll see methods and functions before long. My general rule of thumb, how I like to refer to it, is if we have just a variable, we just make up some name to store something, no extra symbols beside it. Just the name is a variable. That's for storing things. That's a holding place. And then we also have, sometimes we want to do stuff though. In the pre-built ones that we do stuff with, there'll be a name. These were pre-built into language, kind of like print here. Only it's not the name by itself. Right after it comes parentheses. So I like to say the parentheses are like our standard symbol to do something. And that applies in a lot of languages. It's one that applies in more languages than it doesn't these days. So if we have a name by itself, that's storing something. And if we have a name followed by parentheses, perhaps something inside of those parentheses, that's saying to do something. So we're going to print, and then all of this stuff. And that gave us a problem because X was an integer and we can only print strings. So we need another function, which we'll talk about soon. I think week 3, module 3. I shouldn't say weeks because we're on a Wednesday to Tuesday schedule. We'll call this pre-built function that turns an integer into a string for us. And then by the end of the semester, that's an important one, right? Written language, that's how humans have stored data for a long time. So when we get to making our own things later in the semester, we're also going to want to remember that we need to define how we turn our custom things into strings. If somebody says to print it, what does that mean for a custom thing that we made? Which obviously is unique for the situation, but we will see that later in the semester. Today is about environments, so that actually needs to happen on all of these. And once all those are fixed, you can hit run. So I'll push F5 here on my laptop again. And if you forgot to save it, you'll get the little message here that says source must be saved before it can be run. So you guys save it and then it'll run. And this time we got the expected output. First number is 13, second number is 15. Their sum's 28. Kind of trivial example there. But that's the first thing in looking for problems, is these error messages. And this error message is from the language itself. If I come over to say command prompt, so I saved this folder in my delete file, so I'm going to open command prompt. To do that on a Windows machine, if you hit Windows X, Windows and X key, you'll get the management functions. And on that list, you should have either command prompt or PowerShell. I'll just go in the old style command prompt. All of the old command prompt instructions do work in PowerShell. They added things to it like a full scripting language, which is very, very similar to Python. That's something I've done in this class in the past. After we've seen all the concepts in Python, I like to look at that scripting language in PowerShell, because that's the operating system scripting language. A very, very useful one to know. And the last 2 times it took about 45 minutes to get through it, because we know what all the tools do. We just need to see the syntax form in Python. But that'll be about week 6 or so. Or sorry, in that case, we need to see the syntax form in PowerShell, not just Python. And that expands the knowing a language, which is what most of this semester is going to seem like we're studying a single language, but we are studying languages, plural. These things will apply. So here in command prompt, I'll change directory. I'll go in my documents and delete folder. That's where I saved that. Pull up the listing to make sure it's there. Okay, there it is, example _idle.py. And I can run that here by typing the word Python, start the Python interpreter. And then I'll pass in the instruction example _idle.py. And then that'll run the code. And if there's an error message, so I'll go over here and put an error in here, this file somewhere. I'll take the I out of one of the print statements. Because what we're doing here is looking for errors. So you see, we get error messages here as well. I put a typo in there just to show that those error messages, the traceback error messages, those come from the operating system. So no matter where we're running our code, you'll see the tracebacks. So that's not really one of our primary tools, but it is a critical thing that we will use. I guess that's the first thing we always want to check. Let's look at this one, since it's on the screen here. Again, we have a traceback. Oh, not black on this one, red. Again, we have a traceback, so something went wrong. So it's going to run the last few lines, and it's going to try to tell us what line it is. But just beware that computers are not intelligent. So it's trying to tell us, it tells us the program crashed on line 8. But does that really mean the problem is on line 8? Any thoughts on that? If the computer says, okay, something's happened on line 8, does that tell us explicitly that the problem is on line 8 and only on line 8?
It could be the line
No, it
before.
does not.
It could be before. The only thing that tells us is that it is not after line 8. is Python is an interpreted language, which means lines run one at a time. We don't compile a huge file of it. We compile line 1 and run that. Then we come back and grab line 2, translate that into machine language, run that line, come back, grab line 3, interpret that Python code into machine or assembly language, something the machine can deal with, to run that. So one line at a time. So if there's a problem, it says the problem's on line 8. The only thing we really know is it didn't happen after line 8, but it does narrow it down. And this time is a name error. That means it didn't recognize something. In this case, PRNT is not defined. It's supposed to be the word print. That was put there on purpose. So I already knew what it was, but I wanted to talk about that error message. So we always have those. So that's the first, I guess that's the first place to look, is those error messages, see if that helps. But sometimes that might not be enough. Like, what? That doesn't make sense. So we have debugging tools. Does anybody know the origin of the word debugging?
Didn't it have to do with like a military computer with a bug inside it?
Yes. Grace Hopper, a name worth knowing if you're going into the IT field. She was one of the original developers of it. She was a lady that made it all the way to rank of admiral in the 1950s and 60s. To tell you what an amazing person she was. But she was one of the ones that developed, actually put the machines together and got them working. And one day it wasn't working. They knew the code was good, so she took the machine apart, trying to find the problems. Like, okay, the code, the software is good, so it has to be a hardware problem. She took the machine completely apart and found a moth that had flown in there, attracted to the heat and the light from the old vacuum tubes, and shorted out the circuit. And this was a military project, so she had to write reports. Obviously, I had to write a report on it, so she took that moth, put it in a plastic bag, and described the incident as had to debug the machine. She had to actually take a bug out of the machine to make it work. And that term just stuck around. We call our problems bugs, and when we go to fix them, we need to debug them. So our integrated development environments, most of them have debuggers in them. Here in IDLE, if you go over to the shell, you'll see in the main menu, there's things that debugger. So we go to that. Before we run the debugger though, I'm going to click this option a couple lines down. It says auto open stack viewer. Whenever there's a problem, that thing will open. So I'm going to click auto open stack. A stack is a way of processing, shows every instruction. Because I wanted to point out this list, I mentioned Python is a terribly inefficient language. So if I start expanding these folders, you can you'll get a sense of how many scripts have to run just for this simple code we ran here. And it didn't even get all the way through our script. But you'll see, I didn't even expand stuff, and that's a pretty long list. It takes a minute to scroll through the folders and everything holding that. So Python is not the most efficient language. There's a lot of scripts that run in the background in order for us to have all the easy features in the foreground like we do. I just wanted to point that out. So I'm going to turn off the stack viewer. At times you might need the stack. That's a debugging tool, but that's beyond where we're at right now. We're going to start with the simple ones. So when we open this, you'll see there are a few buttons and some output things, different things we can look at. The stack. A stack is a way of processing things, and it's last in, first out. So like a stack of plates. Right? After dinner, we go wash the dishes, dry them, and when we go to put them in the cabinet, the last plate to get put away is probably the first plate to get grabbed because it's on top of the stack. And when we run computer instructions, they run the same way. The computer piles up all the instructions, and once it has them, it takes off the last one and runs that. Then takes off the next one. So the last instruction to get fed in is the first one to get run. So when we write like Python code, or most of our languages is like this, we put it in that sequential order, and then it gets read into RAM backwards. So then the last thing to get piled on the stack was the first line we wrote, the first line in our code. So computers process based off a stack. Locals, that's the local variables and global variables. These checkboxes determine what we're looking at. And then some buttons. The most important one is this one right here. It says step. Where's my little pen? Let me draw some circles around that. And point at it. That button right there, that's the one, that's the most important button for us in all our debuggers, is the step button. So even if there's really fancy debuggers, like we'll see in Spider here in a few minutes, much nicer than this one, that's the first button we want to concern ourselves with, is which button is the step button. Because what that does is that goes line by line through our code. Instead of running the whole thing, once we open the debugger, I come back over here and click the run button. You'll see this little window open. And what it do? So all it's done at this point is it's loaded in the main, which we only ran one script. So obviously that one script we ran is the one that was called main in this instance. And that script has been loaded in. Only one line is run. If I look back over here, you won't see any marks or anything. Then hit the step button, and that basically runs the next line of code, which you can see down at the bottom there of the stack viewer. You'll see a bunch of different variables. This annotations, that first one, that's going to be beyond the scope of this class. We can put special things in our we can put special instructions in our comments to change how the code runs. So comments aren't just for documentation. We can do things with our comments as well as our code. Because just like the Python code, a comment is just a bunch of text. It's just a bunch of text there. So we can do things with that just as well as that, but we won't see much of that this semester. Built-in stuff, doc, all of this is things with the language. Name is the script that's running. That might be important. I just want to make sure the correct script is running. If there's only the first one, the one you actually hit the play button on, so most of our software is going to involve lots of scripts. The first one you run in Python, or you hit the play button, is going to be named main, and everything else, you should see its own name. That'll be important later. Package, and eventually down here, you'll see it's the very last thing, X is 13. So that's how far it got. It ran the line that assigned a 13 to the X. So it ran this line, and then up here on this window, you'll see it says Y equals 15. So that's the next line that needs to run. So when we hit the step button, it runs that line. And you see down at the bottom, now it knows X is 13 and Y is 15. And it's getting ready to run this next instruction. When we hit step, well, then we get on the error. So we can walk through one at a time, keep track of the watch window and all that, and step through the code line by line, one line at a time, until we find the problems. So we hit the problem, so it already crashed. And then when you're done, just close the debugger. And you'll see over here in the shell where it turned the debugger on and then turned the debugger off. So keeping track of everything. But that's one of the main things that we want in a IDE, a way to break down and analyze our code and see what's going on with that. There's also a telemetry issue. I'm going to skip that for now. We'll come back and look at that later, like how efficient is the code, how much of the RAM are we using, stuff. But to start with, I want to look at for the troubleshooting features. And we're getting ready to look at better ones. Idle, if you installed Python, you have idle. So you have those features we just looked at. I guess one that's important to a lot of people is this white screen kind of hurts our eyes after hours and hours. Or also it depends on backlight. Personally, I like to use white screens in the day and black screens at night. So that way it feels like it's easier on my mind, on my eyes. On the mind, it's still just hard work. I don't know why that really loud. But switch those around, customize the colors, make them the font bigger or smaller if we're nearsighted or farsighted. Whatever makes it easiest to work with. Make it the colors we like. So if you go up to options, you'll see an option for configure idle. And you can change the fonts, the colors that things have in them, keyboard shortcuts, a bunch of different things to change. Probably start by changing colors and stuff. That's usually a good place. Go to options and then under, I think under general. Oh, is it under highlights? But during my way. Yeah, then we can change the foreground and background colors. Like maybe for foreground color. Well, I'll use the preset here. Custom theme and switch to just this dark color. Maybe you find that easier on your eyes. You stand out a little more. And then you can customize all those colors by going up here. Choose color, maybe a blue color for shell error. So if we hit an error, it'll be in blue instead of red. But that's where the color customizations are. A lot of people like to do that. So I guess that's kind of an important button. But still, this is the one, this is the generic one built into the Python, or that comes with the Python programming language. So we probably want something better than that. And there's lots of options. One that I really like is an IDE called Spider. I'm going to go ahead and close out of this. Several people said that they were interested in, they didn't like the way Spider looked. Whoops. I clicked something wrong there. So I have it installed on here. It's supposed to be installed on these machines. It was on the list of software to be installed, but when I looked a few minutes ago, I didn't see it here on the school machines. Excuse me. Take just a second to load. But Spider is an IDE that was written entirely in Python. That's one of the things I like about it for classes like this is it shows the power of the language. It's a really nice IDE built. Everything about it was built in Python. It was originally developed for AI deep learning research. And as such, there are a lot of nice features in there. A lot of tools to help us track down things and keep track of what's going on everywhere. Just in general, just some nice features to work with. I'll close out of this. So it should look something like this by default. Oh, there it goes. You'll notice the console looks different. Right? Over in Python, so down here's our console. Over in Python, we had 3 angle brackets. Here we have, it says in, and then tells us which input number we're looking at, like a list. This is called the IPython console. It's not the default one, but it has some advantages over the generic default Python shell. So kind of a better prompt there. What did I put on my notes here? Okay, yeah, so that was everything you wanted to look at in idle. So yeah, I really like this. First thing I put in my notes here is it does come with its own customized installation of Python. Like here in on my laptop, if I push Windows E to get into File Explorer and navigate into my hard drive. So on the C drive, the users folder, whichever user account, there's a thing called app data, which is a hidden folder. So you have to turn on hidden folders in order to see that one, to click your way into it. But in app data, it's a folder called local, and local has a folder called programs. And this is the default installation of Python. So unless you put it somewhere else, this is where it'll be. And there's where the Python I normally use is, the version I normally use. But you notice right next to it is a folder called Spider. So it has its own installation of Python with the Spider one. So if you already had Python, like you've customized it or plan on customizing it, it helps to point to the installation you want. And that's one of the options we can do. We have control over this environment. We have full control over how we develop our code. The tools are just here. So if you want to do that, I can go up to Tools and Preferences. It's actually there's a new way to do it that I haven't been able to check because my computer was set up on the old way, and when I tried to erase it and attempt the new way, when I tried to erase it, it created a log file so it kept track of that I had done it the old way. So the new way, all we have to do is say which one we want to use. So if you come down to Python interpreter, and this is where you'll go for all the things like the appearance, the colors and stuff like that, different options on the editor, how we run it. If you go to Python interpreter, you'll see here there are two options. The default, that's the installation that came with Spider, or we can use a different one. And for that, you want to point to the other installation of Python you want. So you may have noticed in that email that was sent out yesterday, Python 3.10 did come out earlier this month. There's some nice features in that. So maybe you want to use 3.10, which isn't what comes with Spider. So in that case, you would just need to point to that. Well, I think the easiest way to get it is if we use idle. I briefly pointed this out. We go over and open idle, the one that comes with Python 3.10 or 3.9 if you install that or whatever installation. If you go to the text editor and open a new file, before you change it or anything, if you go to the save button, it's going to try to save by default to where Python is installed. So if you just come here and click in the address bar, you can copy that address, and that gets you the new installation down to the folder. So I come back over to my File Explorer and paste that in. Here's the installation I want. I need the Python interpreter, which is the application. So in that address that I just copied from idle, pasted it into File Explorer, and on there is one that just says Python, the .exe file to list as application, or you check properties. That's the Python interpreter. The one, if you just double click on a Python script, it opens with the black window, looks like the old command prompt. The thing that actually knows what the keyword if means. The thing that runs the Python. That's what we want to point towards. So over in Spider, if you're using that, just paste that address in, and then at the end, it's /python.exe is the file you actually want to use. And
So
when
for this,
you get OK, and it should run. Yeah.
so for this class, is it suggested we use the native interpreter then?
Whichever one you want to use. Several people in this class are also in a game development class where we had to add Pygame to our installation. So if you're using Spider, and then need to add something to it. The installing things is different if we use the Spider installation. We have to use Anaconda, which is a little more complicated than the general installation of PIP. I have not been able to try the new way, because like I said, my computer remembers the old way. Which your question there, was that Justin? That's that. Okay, yeah. So the main thing, the reason I do that is for installing stuff. Because whenever we need to customize our install of Python, for example, my 1 to 5 class on Monday and Wednesday, the first 2 weeks we're using Pygame to introduce all the concepts before we get into the super complicated game engines. Using the nice simple scripts to introduce some concepts. So to install something, we use the preferred installer package, is what they call it. It came with your installation of Python, which is pip, and then we can say like install Pygame. And when we run that, it's already installed on this computer, so it's going to take a couple seconds. And, yeah, it tells me it's already installed. The old way, what didn't work is you do have to use pip to point to another one. So if you change to point to the other interpreter and it still doesn't seem to work right, you can come over and do pip install spider -kernel. They say we don't have to do this anymore, but if you run that instruction in the command prompt or PowerShell or something, so pip install spider-kernel, that has the extra parts that you need for the IPython console and some of the background features that may not have been in the initial install of Python. But that would be missing, but you do not need that for this class. I just wanted to go ahead and include that and show how to point to another installation in case it was needed. And well, might as well show this. To run pip, you want to make sure that your computer knows about Python. And if you're on a Mac or a Linux, there are parts of the Unix kernel that those operating systems are built on that were written in Python 2. So it has to be there for backward compatibility. So on a Mac or a Linux, if you type Python, it's going to try to run that Python 2. So on those, you want to make sure and type Python 3, because Unix systems will have Python 2 installed by default. So you have to explicitly say, I want to use Python 3, not Python 2. Otherwise, all the instructions will be the same across the platforms. And that's really not different. That's just that a Mac will always have at least 2 versions of Python running. If you type the word Python in a command prompt or PowerShell, it should tell you what version it is and then show the Python prompt, the 3 angle brackets. Then you can just type exit with parentheses, that method, the Python exit, not the PowerShell exit, and get back to the regular prompt. But if you get an error message, that means you need to set up a environment variables. And this is what we've got to do on your laptop after class this evening, Zach. So environment variables, that's what your operating system knows about. We used to be able to get to them from the control panel in Windows, but they've been changing it. So the new way is you have to hit Windows X to get to our control features. And on here, you'll see the button for system. And so Windows X gets all our management features, and under system, it'll open up the settings window and scroll all the way to the bottom, and you'll see advanced system settings. And get this little tab. And under the advanced tab, there's a button that says environment variables. And this is the thing that the stuff the computer knows about, the operating system knows about. So this applies to all of your programming languages. On a Windows machine, if you install a programming language, you want to make sure the machine knows about it. So in the environment variables, the things it knows about, one of those variables is going to be called path. And so scroll down and find path. And that is where all of your programming languages should be installed. And other things. If we edit, you can see it's a big list of things. So that that address I just said, copy and paste over from idle. If your command prompt or PowerShell does not know about that, you would come over here and just add it to the list. So you see it, it's already on my list. We just add it to that and save that, and then restart your command prompt, and it will know about Python at that point. And then you can just type pip install spider kernel if you need to. If anybody has trouble with that, let me know. We're going to have plenty of lab time tonight after we talk about IDEs. That's an important one for all of your programming languages. If I open that back up, I recently cleared it up because it was getting very cluttered. You may have noticed when I zip through File Explorer on this screen share that my hard drive is all red. I don't have much space left, so I recently cleared it up, but I've got a few on here. So there's Java, PowerShell scripting, OpenSSH. This is for building executable files afterwards. Apparently have another version of Java, some MySQL stuff in Python, Putty, and some other things like Sublime. It's a really nice text editor. So I added that to the command. I added that as an environment variable, so I can just take command prompt type Sublime, and it knows, and the machine knows what software I'm talking about. So if you want some software to like shortcut where you can just quickly open it with one word command, that's what environment variables are for. But most directly in this class, the path environment variable is where the programming languages the machine knows about to go. So that's how we get to that. Looks like it's right about an hour into the video. If you want to make a note that talking about environment variables was about an hour into the video. If you have trouble with that later, then yeah, you type Python, you should see it go to that shell prompt, looking prompt like we saw when we ran idle. And we can just exit out of that. And if that works, then do pip install spider kernel is the old one. We used to have to install this manually, but the latest version of Spider that is supposed to be included, but I have not had a chance to check that myself. Is anybody using a Mac or Linux using Mac? So on okay, so a couple Mac users.
Yeah.
So on a Mac, you do have to specify Python 3.
I'm getting that installed right now.
Why don't I do this on my Mac so it'll actually run? I brought my Mac kind of anticipating that. It should just take me a second to log onto the Zoom call here. Macs are quick.
Yeah, I checked my version and I was on 2.7. So yeah, like I said, I'm getting updated at 3 now.
Okay, yeah, so 2.7 has to be on there. So,
Yeah.
for backward compatibility. I don't remember. Yeah, Mac's quick. That boots up way quicker than the other thing. There are some advantages to it. I have multiple systems for software development, right? We want to test it on different systems. And I don't want to just test it on a virtual system because that's not quite the same. So my desk is covered with different laptops and different operating systems at home. Oh, it's supposed to be connecting. Oh, I don't know why. Sorry. I have to connect to the Wi-Fi. Oh, I reset. Okay, now I'm on the Wi-Fi, so I guess I have to try this again. Oh, let's sign in. Join the meeting. This guy. 922. Yeah, I anticipated some people would be on here. That's what I probably should have already logged on this. Don't need the video. Here. And okay. So does your all's MacBook always open Zoom up in a terrible place where like the buttons are behind the dock and have to do all kinds of adjustments to get started? Mine does that like every time, and I haven't figured out how to stop it from doing that. Okay, so on a MacBook or a Mac, you go into terminal, and yeah, Python is going to be 2.7. That's for backwards compatibility. We can exit out of that. And you should have Python 3 on there. So when you type Python 3, you'll see the latest version. There are a couple really nice features in Python 3.10. So when I did finally get around to looking at those this weekend, I thought, well, I think I will show that in a new class because they're going to need it before long anyway, including one that I've been waiting for years. If you don't have it, probably use Brew to install it. All this should look familiar to you Mac users, right? Use Homebrew to install Python 3.
Yep,
Yeah.
I'm doing that. That's what I'm doing right now.
Okay, so that'll run through everything. And then the pip, the preferred installer package, to run that, you have to explicitly call Python 3 so that the Unix system directories know where to look. And then -m, because programming languages are built up of modules, which in the case of Python, the Python programming language is built up of pre-built code we can use. The symbol tools are already built into a bunch of methods and organized into files we call modules. So Python 3 -m for module, and then pip install whatever you want to install that wasn't part of the original language. So you might need to do spider -kernel like that if you're on a Mac. Anything else? Well, I got the MacBook here. I think that's the basic ideas for that. Yeah.
So which was I supposed to do?
So yours, you're going to need to set up environment variables. That's what seems to be missing. We'll get that in a little while. Or it's in the video. It was about an hour into the video if you want to check the recording later. Let's see, that's an hour and 10 minutes. So that kind of gets us up to the point of we're ready to look at this editor, but we've been at this for over an hour, right? Probably a good time to take a short break. Does that sound good to everybody? Have a quick drink. I know I'm starting to get thirsty. So see a thumbs up there. Oh yes, I forgot to state it the other day. I have found that on Zoom calls, that hopeful light thing, maybe I did state it the other day. Just a reminder, that hopeful light thing that's been drilled into our heads to raise your hand and wait quietly, that doesn't work in a Zoom call. Or like here in the classroom, people here raise their hands, I can see it. But on the Zoom, I may not notice those hand gestures, or I may not see everything pop up in the chat room. So on the Zoom call, just interrupt me. I found that's the only thing that works on Zoom. You just have to yell. Please don't carry that to other classes, because other instructors might feel very, very different. But I found if you have a question, you just have to yell it out and interrupt me to ask the question. But why don't we take 10 minutes? Does that sound good? And we'll get back to this at 7:22 and look more at the spot where we write code and the tools we have to work with to make it easier. Because that's an important aspect of it. So we'll get back started at 7:22. Okay, looks like the battery's good. So I'm gonna pause the recording. Or